In today's lesson, you will learn to divide radical expressions. The process is also called rationalizing the denominator. Mathematicians have established a standard convention writing all answers involving radicals with the denominator free of the radical sign. That process is called rationalizing denominators. The purpose is to allow us to compare answers. Also, we need to rationalize the denominators in order to determine whether radicals are alike. If they are alike, then they could be added or subtracted. Division has a rule similar to the one for multiplying. If you have the nth root of a divided by the nth root of b, that's the same as the nth root of a divided by b. In order to divide radicals, you have to have the same index. Let's look at an example. Let's look at the fourth root of 25x to the 8th divided by the fourth root of 5x squared. They have the same index, so therefore the radicals can be divided. The answer would be the fourth root of 5x to the 6th, because 25 divided by 5 is 5, x to the 8th divided by x squared is x to the 6th. Remember that to divide powers having the same base, you keep the base, subtract the exponents. 8 subtract 2 is 6. Now you do not want to leave your answer as the fourth root of 5x to the 6th, because I can reduce the x to the 6th. What I can do is I can factor it into what is a fourth and what's not. So I can factor it into the fourth root of x to the 4th times the fourth root of 5x squared. The fourth root of x to the 4th is x, so therefore the answer is x times the fourth root of 5x squared. You will not have very many this easy. Let's look at one in which the directions will be to rationalize the denominator. So we want to rationalize the denominator. The only way I can rationalize the denominator is to take the root. So what I'm going to have to do is to somehow make a perfect cube in the denominator. I'm going to do that by multiplying both the numerator and denominator by the same thing. And I have to multiply by whatever it takes to get a perfect cubed under the radical sign. If I can get a perfect cubed under the radical sign, then I can take the cube root of it. Okay, here's where your table of cubes comes in. If you haven't memorized your cubes, stop the tape and get out your table. So by now you should have made a list of perfect cubes. And if you haven't memorized them, stop the tape and get your list. Now if you'll go down your list of cubes, you will see that your list of cubes has an 8 in it. The 8 is in your list of cubes. If you look at your cubes, you had the cubes. This is a list you should have found. And you've got numerical, you've got literal. Under the numbers, you've got 8, 27, 64, 125, and so forth. Under the letters, the literal, you've got a cubed, a to the 6th, a to the 9th. So 8 is a perfect cube. So I'm trying to get 8. The reason is I can take the cube root of 8. I have x, but I need to get a perfect cube. X is not a perfect cube, but x cubed would be. So I'm going after, well I put a, but it would be x. I'm going after x cubed. So I'm going after 8x cubed. Well, what can I multiply 2x by to get 8x cubed? Well, 2 times 4 gives 8, so I need to multiply by 4. x times x squared gives x cubed. So I need to multiply the denominator by the cube root of 4x squared in order to get the cube root of 8x cubed. I want the cube root of 8x cubed because I can do the cube root of it. If I multiply the denominator by the cube root of 4x squared, then I've got to multiply the numerator by the cube root of 4x squared. Because the rule of math is you must multiply the numerator and denominator by the same thing. Now I cannot actually multiply 4 by the 4 here because this one is out from under the radical, this one is under it. So I would have 4 times the cube root of 4x squared. Now I can take the cube root of the denominator, so I would have 4 times the cube root of 4x squared over 2x. The cube root of 8 is 2. The cube root of x cubed is x. Now I can divide the 2 into the 4 to get 2 times the cube root of 4x squared all over x. I just reduced the 4 into 2. Now that's called rationalizing the denominator. Here there is a radical in the denominator. Here there is not. This is considered to be the standard form so that mathematicians can compare answers. Let's look at another one. Let's rationalize the denominator here. Now your first thought might be it doesn't have a radical in the denominator. Well actually the square root of 5/3 is the same as the square root of 5 divided by the square root of 3. So it does have a radical in the denominator. What I need to do is I need to multiply both numerator and denominator by something so that I will have the square root of a perfect square. So here I've got to have the square root of a perfect square. So get out your list of squares, and you want something from that list of squares that 3 will divide into. So you've got to find something in your squares that 3 will divide into. You should find 9. Now the question is, what do I multiply 3 by to get 9? The answer is 3. So I need to multiply the denominator by the square root of 3. If I multiply the denominator by the square root of 3, then I multiply the numerator by the square root of 3. You must always multiply numerator and denominator by the same thing. So actually you're multiplying by 1, so everything remains the same, value-wise. The square root of 5 times the square root of 3 is the square root of 15. So that leaves us with the square root of 15 over square root of 9, which is 3. Now I'm going to give you the rule in verbal form. So I'm going to verbalize what we have just been doing. To rationalize the denominator of a radical expression, first thing you do is to multiply both numerator and denominator by what it takes to make the denominator the nth root of a perfect power. Multiply both numerator and denominator by what it takes to make the denominator the nth root of a perfect power. Then the second thing you do is you take the root of the denominator. And the third thing, you put your answer in good form. Now that might be involving a little bit of reduction or just rewriting, but you want to put the answer in good form. Let's look at an example now in which we are using the rule.